Okay, well, I'm going to go kind of fast in this talk. This is the first time I've ever given this particular presentation, so it's a little experimental. It's a lot of content that we're going to try and fit into a really small amount of time, so I'm not sure if I'm going to get through it, but we're going to try. So I wanted to start with a quick overview of identity and access management, because I know there's sort of a split between security people and identity people. And so, I'm really more in the identity space. So when I think about the identity field, I think of these four distinct areas. In a lot of identity companies sort of blur the lines because they want to present a complete solution to enterprise customers. But really, traditionally, if you went to get research reports, you'd find reports in these different areas. So just real quick, IDM, or identity management, I think of that as user CRUD. Create user, update user, delete user. Whenever information about a person changes, we need to update various systems. It could be Active Directory, VPNs, add an account in Google or Office 365. So the connectors, and that includes a right of a user could be changing a password. It could be adding a user to a group, which then causes that person to get access to different systems. So IDM is, it's like a never-ending battle for companies. There's always new systems and new workflows. It could include approval workflows. So and not a lot has changed in IDM over the years either. It's sort of like the same problem that we've been dealing with. And so IAM, which is the topic of this talk, is identity and access management. You could think of that as the APIs that applications use to interface with the identity infrastructure. IAG, or Identity and Access Governance, is, you can think of this as like the brains of the system. At some point, you need an inventory of all of your roles and responsibilities, and you need to make decisions about, who should get access to what. So also the IAM system produces a lot of information, so logs and other information, and we need reports on this information for compliance. So IAG, the governance part, is doing how do we make the rules and then push those rules down to the IDM and IAM pieces, and how do we monitor and interpret and comply. All of these services are backed up by some kind of database. In identity, that's traditionally been LDAP, but it really could be any database. It doesn't matter. So the IDM will write to this directory services database. IAM will rely on that. And so really directory services is sort of the foundation for all of these services. So, all right, let's then go into OAuth2. So I'm really going to be focusing more on enterprise, the uses of OAuth2 for organizations and enterprise, and maybe a little less on the consumer space. But OAuth2 started in the consumer space. And so this is the problem that OAuth was addressing. If you've signed up for a certain service, like maybe on your TV, or maybe some of these new fintech services, where you give them your password, that's a problematic pattern, because the service that you give that password to or that credential to can impersonate you, and the end service has no way to distinguish between your TV, who's presenting your password, and you. So this is the original problem domain, is how can we find a way to authorize some service to act on my behalf without actually sharing my password or my other credential. So you've probably used OAuth2. You might not know what it is, but you might have used it. If you've seen this dialog, if you've ever gone to a website and you hit login with Google, Google presents this form that says, is it okay for Google to share this information we have about you with this third-party website? So that is the authorization part of OAuth2. You're authorizing Google to release this information. Now, you're probably already logged into Google. I don't know if you ever noticed, but Google almost never asks you to log in. When I do a demo of Google authentication, I have to go into incognito mode and make sure I have no cookies. If you weren't logged in already, when you hit login with Google, they would first present the password or whatever their credential you have at Google, and then they would present this page. So one of the misconceptions that about OAuth2 is that it's an authentication protocol. One of the authors of a book on OAuth by Microsoft, Vittorio, has this quote that using chocolate to make fudge does not make chocolate equal fudge. And it's sort of a good like analogy to keep in mind. So you can use OAuth2 to make a login flow for authentication, but OAuth2 by itself is an authorization framework. And I'll nitpick on another point, which is to say that OAuth1 really was an authentication protocol. But OAuth2, if you go to the first spec that was written, it calls it an authorization framework. So some of the frustration with OAuth2 was OAuth1 was a perfectly good authentication protocol. OAuth2 is really a nothing it's not a protocol at all. It's a framework. It's sort of a set of common like words and patterns that we use. So there was a lot of frustration about this, but the reason was that OAuth1 was good at solving authentication, but it didn't really address other authorization use cases that we were facing, like can I post on your wall, or there was just other. When OAuth2 was written, the design goal was to address a whole number of authorization use cases, not just the authentication login flow. So if you're familiar with ldap, ldap is not one standard, it's a whole bunch of standards, and OAuth is really the same way. It's really growing. It's also, there's a lot of innovation in OAuth. So this is, as of yesterday, I counted 14 RFCs and 14 active drafts. So that's a lot of content for something that's not even a protocol. And that includes, just to give you an idea of the breadth of the standard, it includes the main sort of the basis of it is 6749, which is the OAuth2 framework. And it defines the main flows and terms and conventions. There's quite a number of RFCs that have to do with tokens. JWT, which is used quite a bit outside of OAuth now, is in the OAuth working group at IETF. But there's also standards that define algorithms. Like if I use AES as the keyword, that's defined in a standard, so we all know that corresponds to a certain algorithm. So there's there's crypto or standards that enable signing and encryption. There's standards that basically normalize different security conventions. It's gotten really quite large. I think some of the original frustration with OAuth was that the first spec didn't really address the breadth of what OAuth1 did, but when you look at these 28 docs together, they're starting to get there. The bottom link is where you can get all of these docs in one place. So let's look at the roles. So in this diagram, I actually have if there's a little character like this in it, it's a person, and if there's not, it's software. So you might hear the term three-legged OAuth. So the three legs would be, let's start with the resource server. That's the thing that has the APIs. That's the content. There's the authorization server. That's the thing that issues the token that authorize, and the client is the thing that's connected to the requesting party, the person who's trying to get the content. So I have some other people in here who are important actors. So at the top we have the resource owner. So the person who's in charge of controlling access to that content. In an enterprise situation, that could be the guy who's in charge of the IAM system, who makes the policies about which groups are, can get to which URLs. We also have the developer in there. The developer plays a pretty active role in OAuth 2. The developer needs to get client credentials and needs to understand how to obtain these tokens. So before I go into the profiles of OAuth 2, I wanted to talk a little bit about sort of the building blocks of OAuth 2. I like to start with scopes. This is really too small to see, I now see. But let me just give you an idea. This page I took, Google has one page. I'll add the URL of that page to this slide. And that page tells you all of Google's APIs and what scopes are required to call those APIs. So just looking at this example, they have a genomics API, which I had no idea. And there's an API that lets you view and manage your Google BigQuery, whatever that is. So the idea is that for each of these sort of like different features in their APIs, you might have to obtain a token with a different scope. So there could be, to make it easy, there could be like a read token and a write token. The convention is, and so scopes is used to sort of specify what are the permissions associated with this token. The convention is to use non-colliding identifiers for scopes. So URLs are good because they're in the context of a domain. URNs, if you even remember what those are, you could use URNs too. So what are these tokens? So there's actually a lot of different types of tokens. The token is what the client is going to present to the resource server in order to say, I have access to this thing. In OAuth 2, in the token response, there'll be access underscore token where you have the token, and there'll be a token type field that'll tell you what kind of tokens there are. The most people tend to think about bearer tokens when they think of OAuth 2. A bearer token is like a sort of a string that's long enough that makes it hard to guess. Actually, OAuth 2 provides some guidelines about how complex it should be. I forget what it is. I think it's like 2 to the 140 to 2 to the 170 or something. So that's a bearer token. And with this bearer token, if you present it to an API, it means you have access to call that API. So the client needs to protect the bearer token. SAML uses bearer tokens too. If you're familiar with SAML, SAML is also using basically a bearer token. OAuth 2 defined this JWT spec. So JWT is a very compact format to send a signed and encrypted JSON. And if you ever look at a JWT, you'll notice that it has at least one and usually two periods. And those periods delimit the parts of the token. So the first part of the token tells you how is this token signed and encrypted. The second part of the token is the actual payload, and the last part's the signature. If the token is not signed, then the signature will be left off, and it'll only have one period. There's other kinds of tokens. So holder of key or proof of possession tokens are more secure. So these require the possession of some cryptographic key in order for the receiver of the token they can be validated cryptographically. That means if the tokens are stolen, they won't do the attacker any good. So they're more secure, but it adds some more security. And then one of the innovations in OAuth 2 is to introduce this idea of token binding, where the SSL channel that the token travels over is bound to the token, so that if somebody steals a token, but they're using it on a different SSL channel, the resource server can reject it.
So JWT is still a bearer token, right?
Sure.
In the sense that that's the only thing that I need to get resource, right?
Yes, all of these, well, actually, the holder of key and proof of possession wouldn't be bearer tokens. Yeah. So one part that's common to OAuth is client credentials. If you've ever called an API that's OAuth protected, you probably notice that you need a client ID and some type of client credential to call the API. So OAuth, so how do you get this, these client credentials? That happens through registration. These are some pictures of how Google handles registration. They have some forms which the developer goes to and they click on, I need client credentials, and they fill out the form and they get their credentials. But this could also be automated via APIs, and there's an OAuth 2 standard for client registration. The most confusing part of OAuth are the grants, and these are sort of the flows that you can use in order to obtain permission. The primary flows that are defined in OAuth 2 is the authorization code, implicit, client credentials, resource owner, password credentials. I have swim lanes for this coming up, so let's just jump into it. So this is probably too detailed for this presentation. OAuth 2 people love these swim lanes. The basic idea is in this flow is that the person is going to, let's look at a sign-in flow, authentication flow using OAuth. So the person is going to hit a resource. The resource is going to redirect to the authorization server. The authorization server is going to ask the person, do you authorize? Remember that screen we saw in the beginning? So you're going to hit yes. And at that point, a code, which should also be some type of unguessable string, is going to flow back to the client. And the client is going to take that code and then present it to the authorization server with its client credentials and say, I have a code, here are my client credentials, I would like tokens. And the authorization server will respond with an access token and potentially also with a refresh token. The access token is used to call the API on the resource server. The refresh token is presented to the authorization server to obtain a new access token. The access token is normally short-lived. I think that there are guidelines in the OAuth 2 spec, somewhere between a minute and 5 minutes, something like that. The refresh token is long-lived. A lot of times the refresh token will be rotated, so when you ask for new tokens, you'll get back a new refresh token and a new access token. But that's the basic idea of authorization code. User authorizes, code goes to the client presents its client creds and gets the token. So implicit flow is used when you have an application that actually lives in the browser. This is basically a JavaScript application. And so it's all a totally client-side application. And in this case, it's a little bit shorter. And what happens is the client asks for a token. Instead of getting back the code and trading the code for a token, the client just asks for a token outright. So basically, the client, the person is redirected to the OP, to the authorization server. The person authorizes. The authorization server returns the token to the client. So this flow it's really only appropriate for for JavaScript clients in the browser. There's no point using client credentials in a JavaScript application in the browser because there's no way to hide the client credentials from the person. So if you see anyone using implicit flow for a mobile application or a web application, advise them against it. That's one of the most common mistakes we see. Now, OAuth defines this resource owner password credential flow. And so in this case, the client actually takes the password of the person, submits it to the resource server, and gets back a token. And if you're thinking, isn't that what we were trying to prevent in the first place? The answer is yes. So don't use that flow. It's in order to use that flow, you have to trust the client. I don't even know why it's there, but it's there. OAuth2, there's a separate spec for something called token introspection. So how does the resource server know that these tokens are good? There's a couple of ways. One way is that the resource server might be the authorization server, so it might actually have that token in a database somewhere, and it might just look up the token and see if it's expired or not. But what if the resource server and the authorization server are different? So think about Google. They have one authorization server. They have tons of API servers. So in that case, you need some way to check if this token is still valid. One way that you can accomplish this is by using JWTs. If the authorization server signs the token and the resource server can cryptographically verify that it's the integrity, then that's good. It's good to go. The payload of the token expiration could be in the token itself. But what if it's just a bearer token? It's just a string. So in that case, we have an API called token introspection, and this lives at the authorization server, and it's a way to take a bearer token and trade it for something that's more readable, like a JSON. And so this is the response that's defined in the introspection API, where the authorization server must return that active equals true, or true or false, but then it can return any amount of information it wants extra about that token. I didn't have much room here, so I could only include a couple of claims, but there could be quite a number of claims it returns. So it's almost like a token lookup service, you could think of it. Okay, so we got through our first profile, 1124, okay. Now, OAuth2 is really handy for the login flow, for authentication. And the most widely deployed profile of OAuth2 is OpenID Connect. Now, there's a lot of details missing from OAuth2 that if you implement, you'd want to know. Like, what is in these JSON tokens? What are the keys? What are the values? What are the conventions for the values? There's all sorts of information that if anybody implements OAuth2, they'll have to make some design decisions about how to do it, really. And so what OpenID Connect does is it gives you the pattern that was agreed on by a number of large implementers of OAuth2, particularly Microsoft and Google. So Microsoft and Google both had OAuth2 APIs for authentication, and the conversation basically came down to, do we really need two different APIs, OAuth2 APIs for authentication? Can't we find like the common denominator of our APIs? And so in a large part, that's where OpenID Connect comes from. It's a combination of Facebook, Microsoft, Google, and other large consumer IDPs, best practices around OAuth2 authentication. So the benefit of this is that those guys had a trial by fire in security. Everybody tried to hack them, and they learned a lot, and they've shared that with the community. So there's a lot of value to be gained by adopting their patterns and best practices. Now, it's sort of confusing because in OpenID Connect, if you read the specs, which are not meant for really developers they're not very user-friendly. But what's confusing is it seems like there's only two parties, and we know that OAuth is three-legged. So how do we get these two parties? So the two parties in OpenID Connect are the OpenID provider and the relying party. If you're familiar with SAML, you might be thinking identity provider and service provider. So they're basically analogous here. All the jargon has to change in OpenID Connect, but basically it's the same thing. What happens the reason that OpenID Connect has less roles is that the resource server and the authorization server are sort of globbed into one unit. So OpenID Connect has one endpoint which is protected. It's called the user info endpoint. And that's where a client would say, give me this person's information. So in our Google example, you're authorizing the release of claims, let's say first name, last name, email, to a client, a website. So those claims are flowing from the user info endpoint. But there's the fact that they're clubbed together means that we only have two actors here. Really, there are three, but one of them's combined. The other interesting thing about OpenID Connect is because there's only one protected endpoint, the user info endpoint, there's less of a need for token introspection because we know what that access token is for. It's for the user info endpoint. So there's no question about what it's for. So these simplifications can make OpenID Connect a little bit confusing to people about why is it three-legged OAuth 2, but it really does fit the pattern. There's one other globbing of roles here, which is that in the first OAuth diagram, we had the resource owner and the requesting party were different. But in OpenID Connect, they're the same. So it's me giving access to my information. So that's why I am the owner of my email address and phone number and name. So that's why I'm the resource owner and I'm the one requesting access because I'm going to a site, I'm hitting login with Google or login with my OpenID Connect provider. So there's a little bit of mushing together, but it really is a profile of OAuth 2. So OpenID Connect, this is off their main website, openid.net/connect, and it shows you that it's OAuth 2, but it's also using some of these other standards. So it's using the Jose suite of standards from OAuth 2, that's JSON Web Tokens that we talked about, JSON Web Signing, JSON Web Encryption, JSON Web Keys, JSON Web Key Sets, JSON Web Algorithms, like that whole set of because we didn't have enough certificate, key, and key set standards, we now have a whole new set of them in JSON. The other interesting thing is that OpenID Connect is also a number of related standards, and the main three of those are core, discovery, and dynamic client registration, which I'll get into in a little bit more. So OpenID Connect introduces a new flow, the hybrid flow. And so remember we talked about implicit flow and authorization code flow, and those are still there in OpenID Connect. But there's another flow that's used by Connect called the hybrid flow. And this diagram I borrowed from Nat Sakamura from the OpenID Foundation, and it's sort of interesting because implicit gives you the goal with OpenID Connect was to make simple things simple, but also to support higher assurance transactions. So, at the bottom, let's say we have plain OAuth. Then we have implicit flow. Implicit flow had no client authentication, so it's not quite as secure. Then we have authorization code flow. What hybrid flow introduces is more signing of the request and signing of the response, and this adds extra security into the protocol. You don't need to use hybrid flow, but if you want to use it to add security, it's there. So this is something that confuses a lot of people about OpenID Connect. So the way that you specify the flow in OpenID Connect is by specifying what's called the response type. So when I first looked at OpenID Connect, I said, well, I want everything. I want ID tokens, I want codes, I want it all. So I would ask for all three. And what I was basically saying is I want hybrid flow. So the idea is like these keywords are used to specify the flow. So if you want to do authorization code flow, you're just going to specify code as your response type. So in OAuth2, we have the access token and the refresh token. In OpenID Connect, there's the ID token. And the ID token tells you the details about what type of authentication happened. So who issued this token? In SAML, that would probably be the entity ID of the IDP. The subject is the user. And that could be your Gmail address, or it could be some type of other pairwise non-correlatable identifier. The audience is, who was this token issued to? If the token was not issued to you, your client ID, you should throw that token out. When does this token expire? When was it issued? When did the person authenticate? If you're Google and you haven't re-authenticated in 3 months or so, in your browser, then the application might want to know that. So also how ACR is, how did you authenticate? Did you use password? Did you use two-factor? There's another parameter called AMR, which can give additional information about the type of authentication. So these things aren't defined in OAuth2. So you need OpenID Connect filled in some of these gaps to really take OAuth2 from authorization to usable authentication protocol. So OpenID Connect defines discovery. One of the cool things about Connect that maybe hasn't really taken off as much as we'd like is the idea that Connect could be used for, let's say, more dynamic provisioning. So I go to a website, I want to buy a jacket. And I've never done business with this website before. So I go to checkout, I put in my email address, mike@glue.org, and the website makes a discovery request to glue.org. It says, I have a user from your domain. I'd like to authenticate that user. So send that user back to glue.org. So make a discovery request. So you just take the Mike@ and you drop it, and you take HTTPS glue.org, and you add on that well-known OpenID configuration, and you get back a JSON object that tells you where are the endpoints for my OpenID Connect service. It has other configuration information for the client, so what type of crypto is supported, what scopes are available, what other features of OpenID Connect are available to you. So here's the registration endpoint. So if you want to get a client ID in secret, you would first call the registration endpoint, get your client credentials, then redirect the person to the authorization endpoint. The person would authenticate, you'd get back claims. So discovery really kicks this off. If you're thinking about SAML, in a lot of ways, this is the SAML metadata. Also here is the JWKS URI. Those are the public keys that are used for signing. So you have everything you need here to basically bootstrap sending the user to this domain for authentication. Dynamic client registration is another interesting one. I showed you the form before of how you could manually sign up for client credentials, but that doesn't scale too well. Also, there's a lot of details about how you might want to configure your client. What are your preferences as a client? What type of authentication? If you're a TV, you maybe don't want to use password authentication. Maybe one feature I think is really important is that OpenID Connect allows the client to register a JWKS, a JSON Web Key Set, So if your client doesn't want to use API key and secret, client ID and client secret, which is basically like password for a client, right? Your client during registration can register its public key, and then during client authentication can use there's a challenge response, so you can prove ownership of the corresponding key that you registered. So, and this client registration is really useful for other protocols. In fact, we use it in the next protocol too. Now, Connect is starting to define logout. There's 2 draft specs, one for front channel logout and one for back channel logout. Yeah. So front channel logout. Front channel means through the browser. So the way that this basically works is you hit logout. Let's say you're logged into 10 websites. You hit logout, and it sends you to the end session endpoint at the OpenID provider. The end session endpoint kills a session in the OP, but you're still logged into 10 applications. Then it returns a page where there should be 10 iframes, and each iframe should contain the logout URI for the back-end applications. The iframes load automatically, so hypothetically they've sort of tricked your browser to call logout on 10 different sites. That all sounds great. There's problems. If you're blocking third-party cookies, your browser might not allow these external cookies to be cleared from within a page rendered by the OpenID provider. Also, the OpenID provider never gets any confirmation that you actually logged out from those 10 apps. So it's sort of like a best effort. If one of those iframes fails, you might still be logged into one app, and no one would really know, you or the OP. Backchannel logout is where the OP tries to make a call to the application and say, this user logged out. So the OP can get a verification that logout happened. However, your browser might not have gotten a chance to clear the application cookies, and it puts more of a burden on the application to make sure that the session's active every time you hit the site. So backchannel also has its own problems. It can be complicated and unreliable. So there's a new effort in the OAuth2 called security events. And really, logout needs to be asynchronous. So there needs to be a way for the applications to register, I logged this session out, and for the OP to be able to query and track that this logout really happened. So the security, and there's actually a number of asynchronous patterns in security. Like account compromise is another one. If you're at 10 websites, maybe one website detects suspicious activity and wants to notify the other website. So there's a number of use cases for an asynchronous infrastructure for sharing messages. Logout is the poster child because logout gets really ugly in the enterprise space too. When you have multiple protocols, let's say you have a legacy IAM system like SiteMinder, you have SAML, you have OpenID Connect, you have CAS, and the person logs out of a CAS site. How do you propagate that message across all those different protocols? It's really prone to failure. One thing you might think about is making sure the applications use session cookies so that if you kill the browser, at least the session's going to be gone. And you have one way to tell the person to be done. Okay, so we're on the 10-minute warning. 5 minutes? Okay, I can do it. So we're in the third profile. This last profile, so what we've been talking about with Connect is authentication. Who is this person? After we know who this person is, we want to know, can this person call a certain API? I've been active in the UMA working group, User Managed Access. It's a Kantara working group standard. And to give you the 5-minute overview of UMA, so we have a person, and that person's using some software, let's say a mobile app or a website. And the person authenticates to the authorization server, let's say via OpenID Connect. And then after that person authenticates, they call an API. And they need to present some token to that API in order to, so that the resource server knows that they're authorized. And the token should be issued by the authorization server centrally. If you're thinking about policy enforcement point, policy decision point, the resource server is the policy enforcement point. The authorization server is the policy decision point. So in plain OAuth 2, something like I showed you for Google, we know the scope. We saw it on that web page, right? We request the token for that scope. We get back the token. We present the token for the resource server. And at that point, the resource server needs to validate it, either via cryptographically by looking at the signing of a JWT or by calling token introspection. So what's the problem with that design? Well, one problem is that the user or the developer needs to know the scope. That's why Google publishes all those scopes. The scopes must be versioned. If Google changes the scope that's required, they need to tell you about it. That's why it needs to be versioned. So UMA introduces a looser coupling between the authorization infrastructure and the developer. So here's the quick overview of the flow. The client, so the person authenticated, and they call that API. And the first time they call the API, they have no token. So the resource server says, no token. And it obtains what's called a permission ticket by registering the requested resource and the scopes with the authorization server. And they return a 403 unauthorized and return that permission ticket back to the client. And now the client says, well, I didn't get the resource, but I did get this permission ticket. It takes the permission ticket, presents it to the authorization server and says, I need a token for this permission ticket. The authorization server evaluates the policies, issues the token. Now the client calls the resource server with the token. The resource server still has to make sure that that's a valid token by either calling token introspection or by cryptographically verifying. So the advantage of this is that the client doesn't need to know the scope. It just calls the API, and it doesn't need to know anything about the scope. So we can change the scopes. It's a looser bundling. Let me show you a quick example. This is my last slide. I just got the 2-minute warning, but that's pretty much it. So this is just an example of how we implemented this at Glue. But we created basically a JSON document that we use to protect. And so we provide the URL, the method, get, post, put, delete, and the scope that's required. So this is used by the API server to register what are my APIs, what are the scopes required, and what are the methods associated with those scopes. So so you can sort of use, like in an enterprise setting, to me, like if you ever looked at SiteMinder, it's a similar thing. The URL is the resource. The scope is sort of the policies that have to be evaluated, or maps to the policies that have to be evaluated in order to give access. So, okay, well that's, I'm out of time. So that was, probably like too dense, but hopefully you're able to follow it somewhat. So I'm the founder and CEO of Glue. Glue is a free open source identity and access management platform. We implement OpenID Connect and UMA and OAuth2. So if you have any questions, feel free to hit our site and download the server for free. So, okay, thank you.